Hello physics class, it's Mr. Ng with sample C out of chapter 6 in your Holt physics book. This one kind of ties in a lot of little equations. We're going to go through the two impulse equations where impulse is a change in momentum and impulse is equal to force times time. But then we're also going to go back to some old school kinematics equations. So let's dig into it. So here, let's first review our equations. We know that impulse, delta P, is equal to the final momentum minus the initial momentum. But that means that impulse is equal to mv final, right? mv is momentum minus mv initial. Good. We also know that the impulse is equal to force times time. Good. So let's dig through that problem. A 2,240 kilogram car is traveling west and it slows down from 20 meters a second to 5 meters a second. How long does it take to decelerate if the force is this much? So let's label these. So 2240 kilograms, that's obviously a mass, right? And then 20 meters a second, is this the beginning velocity or the ending velocity? It's the beginning velocity. So we're going to call this V initial. This is going to be our V final, our final velocity. And this is in newtons, 8,410 newtons. This must be our force. So the variables are taken care of. So let's go through our solution. I think the first thing I would like to do is I would like to solve for impulse. So solution number one, find the impulse. So I know that delta P is equal to, I'm going to use this equation. My mass is 2240. Here, let me clarify it. Again, I'm using this first equation, equation number one. My impulse is equal to mv final minus mv initial. So my impulse is equal to 2240 times the final velocity. My final velocity is 5 minus 2240 times 20. Okay, you gotta forgive me for not putting in the units. I just want to do this as quickly as possible. Great thing about your calculators is that you can do this all in one step. 2240. I'm going to do parentheses just in case. Parentheses 5, close parentheses, minus 2240, parentheses 20, close parentheses, and there you go. My impulse is equal to negative 33,600 kilogram meters a second. Good. That's my impulse. Part two, I'm going to use this equation, part two, all right, to find the time. So my equation is that impulse is equal to force times time. That means time is equal to, I'm just going to divide both of these by force, right? Forces cancel. That means time is equal to the impulse divided by the force. Seems easy enough, so I'm just going to plug in here. Time is equal to the impulse. This is my impulse, negative 33600, divided by my force, which is 8,000, here's my force, right? 8,410 newtons. So my time is equal to, so I just got to divide this by 8410. Okay, oops. Oh, I gotta do the answer. Divided by 8410. There you go. It's around 4 seconds. Don't worry about the negative. There's no such thing as the negative time, right? So here it's around 3.995. If I round up, it's 4. Time is equal to 4.00 seconds. Great.